You've probably spotted it before without giving it much thought. You're on a flight, gazing out at the endless blanket of clouds, maybe catching a glimpse of the wing flexing as the jet cruises through the air. Then your eyes wander to the bottom corner of the window. And there it is, a tiny, almost invisible hole. It looks strange, maybe even wrong. Why would there be a hole in something that's supposed to protect you from the deadly thin air at 35,000 feet? Isn't the whole point of an airplane window to keep the cabin sealed? For many passengers, that discovery sets off a wave of nervous questions. Planes are pressurized, right? Everything has to be airtight. So why would the designers poke a hole in the window? It feels like finding a crack in your scuba mask while diving. But in reality, that small opening isn't a flaw. It's not damage. It's not even optional. That hole is intentional, and without it, your flight would be a lot less safe. Here's how it works. What we call a window is actually a stack of 3 panes, not one. They aren't glass, but strong, lightweight acrylics designed for toughness and flexibility. The outer pane is the real workhorse, exposed to the freezing, low-pressure environment outside. It's built to take the stress of altitude, wind, and temperature swings. Behind it is the middle pane, a backup layer. And finally, there's the inner pane, the one your fingers tap against when you lean in to take a photo. The tiny hole sits in that middle pane. Engineers call it a bleed hole, and its job is simple but vital. It balances the pressure between the cabin and the gap between panes. Without it, the inner pane would end up carrying part of the pressure load. Over time, that stress could cause cracks or failures. With the hole in place, almost all the pressure shifts to the outer pane, which is built for it, leaving the inner pane largely unstressed. So that hole isn't a weakness. It's the reason your inner window doesn't have to fight the enormous pressure difference. Think of it as a safety valve, letting the outer pane handle the heavy lifting while the inner pane acts as a comfortable shield. Even better, the bleed hole helps with visibility by preventing fogging or frost. Without it, the window could cloud over from trapped moisture between the layers. Next time you spot that tiny dot and feel uneasy, flip your perspective. It isn't a mistake. It's proof of how carefully airplanes are designed, down to details smaller than a pencil eraser. To really appreciate that tiny hole, you have to imagine what's happening to an airplane in cruise. At 35,000 feet, the outside air pressure is less than a quarter of what it is at sea level. Step out without protection and you'd lose consciousness in seconds. That's why the cabin is pressurized, essentially inflated like a balloon, so you can breathe normally. But pressure always pushes outward, and airplane windows are part of the cabin's shell. Here's the problem. If every pane of the window shared that load, the stress would be spread unevenly. The inner pane, the one next to you, would experience forces it wasn't designed to handle. That's where the bleed hole comes in. By allowing cabin air to pass into the gap between panes, the hole shifts the pressure so the outer pane bears almost all of it. The middle pane becomes just a backup, and the inner pane feels almost nothing. Think of it like stacking 3 doors. The outer door faces the storm, the middle one acts as insurance, and the inner one is for comfort. The hole ensures the storm pushes almost entirely against the outer door. The inner one just sits there, cozy and calm. That's why you can press your forehead against the window without worrying it's taking the brunt of the sky. And that little feature solves another problem: moisture. Inside the cabin, the air is warm and humid. Outside, the temperature is around 50 degrees Celsius. Without ventilation, condensation would form between the panes, fogging up your view or even freezing into frost. The bleed hole allows a small trickle of cabin air into the space, keeping it dry and clear. It's basically the airplane's built-in anti-fog system, so that tiny hole is doing 2 jobs at once: managing pressure and fighting fog. It's a double win. It makes sure the strongest pane is the one doing the hard work, and it keeps your view of the sky sharp. You might not even notice it most of the time. But it's quietly working on every flight, every day, on every commercial jet. The next time someone points it out nervously, you'll know the truth. It's not a flaw. It's a tiny detail that makes the whole system safer, smarter, and more reliable. Airplanes are built on the principle of redundancy, meaning nothing is left to a single point of failure. That's why every critical system has backups: 2 or more engines, multiple hydraulic systems, several layers of electrical wiring. The same philosophy applies to the windows, and the tiny bleed hole is part of that bigger safety picture. Remember, a modern airplane window isn't just one piece of plastic. It's a layered system designed to work even if one layer fails. The outer pane is the primary shield, handling wind loads, temperature extremes, and pressure differences. But if, in the extremely rare event, the outer pane were damaged, the middle pane would take over. That tiny hole ensures the cabin pressure never builds up against the inner pane, keeping the backup layer ready to step in. This is why incidents of cracked windows don't cause immediate danger. On rare occasions, when an outer pane has cracked, flights have continued safely because the inner and middle panes kept the cabin sealed. Pilots usually divert and land as a precaution, but the system works exactly as designed. The bleed hole plays a hidden role in this process, making sure stress is distributed the way engineers intended. Beyond structural safety, the hole also improves passenger comfort. By preventing fogging and frost, it keeps the cabin environment predictable and pleasant. Imagine flying for hours with windows constantly misted over. Not only would it feel claustrophobic, but it could even interfere with crew inspections. A clear view is part of the safety checklist, and that tiny hole makes it possible. It's easy to underestimate how much thought goes into something as simple as a window. But in aviation, there are no small details. Every curve, every bolt, every hole has been tested under extreme conditions. The bleed hole, though small enough to miss at first glance, is the product of decades of trial, error, and engineering brilliance. It shows how even the tiniest feature can make a huge difference at 35,000 feet. So why does this tiny hole keep fascinating people? Because it seems counterintuitive. When you're inside a pressurized tube flying miles above the ground, the last thing you expect to see is a hole in the window. It taps into a primal fear that the cabin could leak, that the thin line between safety and disaster isn't as solid as it looks. But the truth flips that fear on its head. That hole isn't a weakness, it's a safeguard. It proves that engineers thought through every scenario, even the unlikely ones. It shows that passenger safety depends not on brute strength alone, but on smart design. A hole the size of a pencil tip helps distribute tons of pressure, keeps the windows clear, and adds one more layer of reassurance to your flight. For nervous flyers, this knowledge can be calming. The next time you look down and see that little dot, you can remind yourself, it's there for you, not against you. It's the reason your inner pane doesn't have to fight the elements. It's the reason your view of the clouds isn't blocked by frost. And it's one more example of aviation's obsession with safety. The bleed hole also tells a bigger story. Aviation isn't just about speed, wings, or engines. It's about details, thousands of small, often invisible decisions that make air travel the safest mode of transportation on Earth. Most passengers never learn about them, but once you do, you realize how much thought is hidden in every flight. So next time you board, lean closer to that window and spot the tiny opening at the bottom. Instead of wondering if it's a mistake, you'll know it's the opposite. That little hole is part of the reason hundreds of passengers and crew can cross oceans daily with peace of mind. In aviation, trust is built not on what you see, but on the brilliant design you don't always notice.